In this video, I'm going to be going through the pages 210 through 211 assignment, and I know I did a couple in the other video that I posted, but I will probably just take that one down or leave that one up, and then also just redo them in this video so that I've got them all in one video. All right, so for number 2, it says, which triangle does not belong with the other 3, and explain your reasoning. So on this one, this section is all about similar triangles. So we've got a 35-degree angle, an 82-degree angle, and a 63-degree angle. Well, 35, 82, 63, 35, 82, 63, 35, 82, 63. This one has an 85 and a 63 in it, but it has an 85 and a 32. So the angles in the blue triangle are not the same as the angles in the other 3 figures. So the blue triangle, and I'm going to call that triangle, give me a second here, triangle JKL does not belong with the other 3 since it is not similar to the other 3. It does not belong with the other 3 triangles since it is not similar to the other 3. Alright, so in order to be similar, it has to have all 3 of the same angle measures, and it does not have all 3 of the same, so it doesn't belong. Alright, numbers 5 through 12. I did number 5 in my last video, but I'll do that one again. So on number 5, it says tell whether the triangles are similar. So on this one, you are trying to see if they have the same angle measures. So how do we find the measure of this, this angle with x degrees? Well, the angles in a triangle add to 180 degrees. So I would say 39 plus 34 plus x. So those angles in that triangle, if I add them up, it should equal 180. Combine your like terms on the left there, 39 plus 34. You get 73. 73 plus x is 180. Subtract 73 from both sides of the equation. That will cancel on the left side. You get x equals 107. So that is the process to finding the missing angle measure. But ultimately the question says, are the triangles similar? So we're not done just yet. So to keep moving here, we need to find the angles in the other triangle. Well, if you actually look at this, this is 107, so this angle is 107. We have 107, this one has 107. We have 39, this one has 39. So the only other possible angle measure to make 180 degrees is 34 degrees, so this one has to be 34 degrees. So you don't actually have to do the work, you don't have to set up another equation. This one has to be 34 because we've got 2 of the other same angles. So these are similar triangles. So number 5, the triangles are similar. The triangles are similar since they have the same angle measures. Going on to number 6. Number 6, do the same thing. These angles have to add up to 180 degrees. So 36 plus 72. 36 plus 72 plus x must equal 180. Add your like terms together, you get 108. Subtract off the 108 from both sides of the equation, and you get x equals 72. So in this first triangle, you have 72, 72, and 36. In the second triangle, you've got 75, which we don't have a 75-degree angle anywhere in this triangle. So right there, we can stop and say the triangles are not similar because they do not have the same angle measures. Going on to number 7. In 7, again, we've got the same process happening here. So we have an 85-degree angle and an 85-degree angle. We have to see if this one right here is 26, and we'll try to match those up. So let's add up our angle measures. 64 plus 85 plus x must equal 180. Combine your like terms. So we're going to go ahead and add 64 and 85 and get 149 plus x is 180. Subtract the 149 from both sides of the equation. And we get x equals 31. Okay, so if it's 31 degrees, in number 7, if x is 31, We have 85, 64, and 31. Well, here's 85, but even if this is 64 or 31, we don't have a 26-degree angle measure in our first triangle here, so the triangles are not similar. So I'm just going to copy what I put down over here. The triangles are not similar because they do not have the same angle measures. Number 8. Let's see, we've got a 48 degree here, a 48 degree angle measure there, so we're trying to see if this one here is 51 degrees. All right, so let's see. If we take 81 plus 48 plus x, they must equal 180. Their sum must be 180. Combine your like terms, so get 129 plus x is 180. Subtract the 129 from both sides of the equation. We get x equals 51. So on this one, we've got 81 degrees, 48 degrees, and 51 degrees. Well, we've got 48. The 51 matches up with our x degrees because we found out that x is 51. And then there's two of the same angles, so there's only so many degrees left to go to make 180. This has to be 81. There's no other option. So on number 8, it's just like number 5. The triangles are similar since they have the same angle measures. All right, number 9. Keep on moving. On number 9, number 9 says describe and correct the error in using indirect measurement. So on this one, they did 16 divided by 18 equals x divided by 8. I would have set this up as 16 divided by 8 equals, they started with the side across from the right angle, so you have to start with the side across from the right angle, 18 divided by x. That's one possibility. Or you could say, if you start with the variable, you could say x divided by 18 equals, if I started with the horizontal piece, I need to start with the horizontal piece of my other fraction, 8 divided by 16. So either way, their initial proportion is set up incorrectly. So they could have set it up either one of these ways, and they set it up incorrectly. So I'm just going to type that right here. They set up their initial proportion incorrectly. All right, going on to number 10. Yep, we had to go through 12. So number 10. The triangles are similar. Find the value of x. So these, you just match them up. So you can tell that this is 110, 110. It says they are similar, so this must match up with 50 degrees. So x equals 50. Nice and easy. Number 11. Same thing. This one you're going to have to spin around, so you match up the 90-degree angles. So it's like you're cutting this out of the paper and spinning it around. You're going counterclockwise, and you're going to match up the 65 degrees with the x. So x is 65. So those are easy. I should at least say they are quick to complete. All right, number 12 is the treasure problem that I completed in the other video. So on this one, I'm not going to redraw the triangles. If you need to see the triangles redrawn, you can watch my other video. I just decided I will leave that up on Google Classroom. But it says the number of steps you're taking to go to the treasure is they're shown on the map here. So you go 300 steps to the palm trees, 240 steps to the river, 80 steps to the pyramids, and then x x steps to the treasure. So this is the distance we're trying to find. So I'm going to call the distance x. So I've got x divided by 80. The vertical piece divided by the horizontal piece, x divided by 80. X divided by 80 equals, well, now if I cut this big triangle out and spin it around to match it up so it looks similar to this one, so I'm just going to spin it all the way around, so it's going to be going up this way. If I do that, the 300 is going to be the vertical piece. So I started with the vertical piece on the small triangle. I need to start with the 300, the vertical piece on the big triangle. Divide by the horizontal piece, 240. All right, now I need to solve this equation, so I'm going to multiply both sides by 80. That will cancel out the dividing by 80. I get x by itself. Now multiply straight across, I get 3 times 8 is 24, and I have 3 zeros, so 24,000 divided by 240, and that is 100. So 100 steps is the answer. All right, so that's 5 through 12. Then we have 15 through 20 to finish this out. 15 through 20. All right, number 15, the shuffleboard problem. So we've got a shuffleboard diagram right here. I'm going to go ahead and draw out what I drew on the other video. So I've got one small triangle, a medium-sized triangle, and a large-sized triangle. So a small, medium, large triangle. And now for the small triangle, since this is 9.48 feet, this long side is 9.48 feet, this is 6.32 feet. So if you take the whole thing, 9.48 feet, that's the large piece right here, 9.48 feet. And if I subtract off 6.32, what I'm going to get left is this little piece, segment AB. So I take 9.48, I subtract off this other piece from the large piece. So I take the whole side, subtract off 6.32, and I get 3.16. Well, that's the length of segment AB, 3.16. So that's also this side. And this small side, the base is x, so this is x. The base of the large triangle is 6. And in the directions here, it says triangle DAE. DAE, that's the big triangle. So this is D. D goes here. DAE. We have triangle ACF. ACF. And triangle, small triangle ABG. ABG. It says that in the directions, all of those triangles are similar. That's why we're going to be able to set up proportions. And then it says right here, the lengths of segments AG, so this segment on the small triangle, GF, segment GF, so this is GF right here, and FE are all equal. Well, what that means is if I take 9.48 and divide by 3, I'm going to figure out how long each one of those little pieces is. So take 9.48, divide by 3, and I get 3.16, and that's what the small piece is here. Well, this medium triangle has 2 of those pieces, so I've got 2 3.16s, so I'll just take that, multiply by 2, and I get 6.32. So that's 6.32, that's 6.32. All right, and then let's see, I need to find x, so I need to find x right here. Do I have enough information at this point? Well, look at the small triangle and look at the big triangle. I'm going to be able to set up a proportion. I've got x divided by 3.16, x divided by, let me use a different color for the proportions, x divided by 3.16 equals, so that's from the small triangle, equals, I'm going to set up a proportion from the large triangle. So I started with the base, I need to start with the base, 6, divided by one of the legs, 9.48. And now I can solve for x. So I need to multiply both sides of this equation by 3.16. Multiply both sides by 3.16. Again, when you multiply by a whole number, it's the same thing as multiplying by that number over 1. So same thing up here on this previous example. I'm multiplying over 1. So that's how you can know that, okay, yep, I got to multiply these fractions straight across. My denominator is just getting multiplied by a 1. All right, so x equals, just a little calculator work here, we've got 3.16 times 6 divided by 9.48, and that's 2. So x is 2. The units are in feet, so I'm going to say x is 2 feet. All right, so that's the first part. That's part A. This is part A. For part B, it says we need to find CF. CF, this middle piece right here. All right, so I'm going to set up another proportion. I'm going to say that this is, I don't know, I'll call it W. I'm trying to find W. This length of CF, segment CF is W. All right, so I'm going to say W divided by 6.32 is, I'm going to use the large triangle again, 6 divided by 9.48. Now, some of you are going to look at this and go, well, why do you have to do all this work? It's twice as big. This side, 6.32, is twice as big as 3.16. So every side length on this triangle is twice as big as the previous one. And if you know x is 2 feet, well, then w has to be 4 feet. So if you're sitting there thinking that, nicely done. If not, that's okay. We could still set up this work. So I'm going to multiply both sides by 6.32. Multiply by 6.32. Which is the same thing as putting it over 1. That will cancel out on the left-hand side here. The 6.32's cancel. I get w by itself. Multiply straight across. So I get 6.32 times 6 divided by 9.48, and it is 4 feet. There we go. There's part B. All right, the last little section here, we had to go 15 through 20, so we have 16 through 20 to go, but they are all review questions. So number 16, for 16 through 19, it's just, is the given equation linear or nonlinear? Well, to be linear functions can be written in slope-intercept form. That means y equals mx plus b. If it's nonlinear, you cannot write it in that form. So in number 16, can you write this in slope-intercept form? Well, that's y equals, we have a 5, which would be like our slope, y equals m, but we don't have mx, we have m times 1 over x. So for this one, I'm going to say the function is nonlinear because it cannot be written in slope-intercept form. Number 17 is y equals mx plus b, where b is pi, but pi is just a number. It's approximately 3.14. So yes, this is in slope-intercept form. So for number 17, the function is linear since it is written in slope-intercept form. Number 18, y equals mx. You could put y equals 2x, so that's y equals mx plus b is negative 8. So you could put y equals mx plus b. So this one is, the function is linear since it can be written in slope-intercept form. And number 19, the last one of these questions, number 19 is y equals 6x squared. We have an x squared, a variable squared. That's actually what's called a quadratic equation. This is, the function is nonlinear since it cannot be written in slope-intercept form. There's no way to get rid of that squared. All right, so there is 16 through 19, and the last one we had to do was number 20. I'm just going to put that one right over here. Number 20. It says, which two lines are parallel? Well, parallel lines, I'm going to make a note on here, note. Parallel lines have the same slope. So which two lines have the same slope? We'll just look at the rise over the run. You don't have to use a slope equation, the m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You don't need to do that. You're given a graph, so rise over run. So for the blue line, we're going 1, 2, 3, 4. We rise 5 and run 2. So the slope of the, I'm just going to put the slopes of my lines here. So slopes, I've got my blue line, red line, green line. All right, so for the blue line, the slope is 5 over 2, or 2.5. For the red line, I'm going up 1, 2, 3, 4, and over 2. So this one is, for the red line, is 4 over 2, which simplifies just to 2, or 2 over 1. And for the green line, the slope is rise 1, 2, 3, 4, 5, run 2, 5 over 2, and there we go. We've got the same slope as the blue line. So the blue and green lines are parallel because they have the same slope, the same slopes. The answer is, which one says blue and green, green and blue is C. And there it is. All right, so that is the end of your homework. If you have any questions, please send me an email or give me a call. Take care.